x squared sine of x from 0 to 3. Now, nowhere in here do they tell you how many we're going to do. We're going to do on this one, though, we're going to do 5 subintervals. And so on this one here, I should have had on there with n equaling 5. So remember our delta t is going to, or delta x in this case, is going to be, yeah, I want to write delta x because we're using x. They're not talking about a time curve anymore. Delta x equals 3 minus 0 over n, which is 5, which gives us 3 over 5, or 0.6. So when we set up our subintervals, 0 to 0.6, because it's going to be your 0 plus delta t, and then take 0.6 plus delta t, which is 0.6. So this number here is 0.6 plus 0.6. This is 1.2 plus 0.6, 1.8 plus 0.6, and then 2.4 plus 0.6. Now, do not just go, oh, okay, the last one's going to be 3. Do your math, because this is how you're going to know that you didn't make a mistake back here. Okay, we're going to do all 3 of them. We're going to do left, right, and midpoint. And usually in class, what I would do on this one is I would break up the class and have some people do left, some do right, and some do midpoint. Okay, so on the left, we're going to take the left values. That's going to be the one on your left. So 0, 0.6, 1.2, 1.8, and 2.4. I want the height of each of these rectangles. And what I can do, and I should show this up here, is if I'm doing, this is 1, 2, and 3 over here. If I'm doing 5 intervals, they're at 0.6, so about 1/2 would be here, so 0.6 would be about here. But on my left, I would have nothing underneath that curve. So it's going to be 0. At 1.2, let's say it's right about here. The 0.6 is here, so I would come up to 0.6, and then that would be my rectangle. And at this point now, you should be going, oh, it looks like we're going to have an underestimation. What's going to happen here is we have concave up, and then somewhere around here, it's going to change and go concave down, which is actually to our benefit, because we'll start with an underestimation, but we'll end with an overestimation, or possibly, and things will work out. Let's see. So on this one, this itty bitty little area here, if I plug in 0.6 into x squared sine of x, I'm going to get 0.203271. And then at 1.2 to 1.8, 1.8 is going to be right about here, but I come up at 1.2. and make my rectangle. And again, you're seeing there's a lot of information here that's not getting grabbed. So we're going to have an underestimation all along through here. So we put in 1.2 into the calculator, we're going to get 1.342136. And then this is 1.8, and at 2.4, let's go right about here's 2.4. So I would extend this rectangle up to here. We would go over to about 2.4 and come down. There's that rectangle, and I'm going to get 3.155266. And then at 2.4, which is right here, we extend that out to 3. And there's the only bit that we're grabbing that's not that's not under the curve. But you can see we got a lot more that we didn't catch than what we did. This is going to give me 3.89066. So our area is going to be 0.6 0.6, which is our delta t, or our bases, times all of our different heights. Well, this guy is still 0. This guy is going to give me 0.121962. This guy is going to give me 0.805281. 1.893159, and last but not least, 2.3344. Now keep in mind in calculus, you only have to round to the 3 decimal places, so you've got to make sure that you're still including more than 3, because in the end, you're going to round, not in the middle of it. You add all of those values up, and you're going to get 5.154802. That is our value, and we're going to get an underestimation on this guy. Okay, so let's try the right one. So right, unfortunately, I didn't bring the picture of the graph over, but we can kind of identify that it did this bit and came back around from 0 to 3. But when we do the right Riemann sum, this time we're doing right, nothing's changing. Our delta x is still 0.6. Nothing's changing. But now, if I was to go, well, here's 1, here's 2, and here's 3. Okay, I'm off a little bit. 0.6 is going to be about here. Now I'm going to draw my rectangles over. And 0.6, the next one's at 1.2, which will be about here. We'll come up to the curve, and then we finish our rectangle off. And 1.8, which would be about, this is probably closer to 1.8, so I'll put 2 over here. Again, we bring it up to the curve and over. And then 1.8, 2.4 is about here. We bring it up and then over, and then 3. And there's our rectangle. You can see that this bit is not being accounted for, but all of these are. So we're going to definitely get an overestimation this time. So our right points instead of our left point, so it's going to be 0.6, 1.2, 1.8, 2.4, and 3. Now we already have all of the values for these guys because it's not going to change. Function didn't change, nothing else changed. So on your form, all you're going to do is bring all of those values over. So 0.6 is going to give us 0.203271, or 0.121962. The 1.2, and yes, you can copy these down. You do not have to recalculate them unless you want to double check your work. If you want to double check your work, go for it. 805,281. 1.8 is going to give me 3.155266. And I multiply by 0.6, I get 1.893159. 2.4 is going to give me 3.89066. And I multiply by 0.6, I get 2.3344. And then we have our new value of 3, and at 3 we get 1.27008, and that's going to give me an additional value of 0.762048. Now, if you took the last guy that we had, a 5.15, and add this guy to it, you're going to get your answer of 5.91685. Now, if you're rounding the 3 decimal places, it would be 5.917. And we have our right. So the only thing we have left is our midpoint, which should give us a more accurate answer. So midpoint, again, graph hasn't changed. It's going to come up. It's going to do this bit from 1 to 3. I appreciate your being patient with me. This is 3. If I split this in half, that would be 1.5. Split this in half, 1.5. So we're going to put 2 about here, and we'll put 1 about here. 0.6 is going to come right about here, but our midpoint, we can't do our rectangles here until we have our midpoint. Our midpoint here, 0.6 divided by 2, 0.3. And to get your midpoint here, do 0.3 plus 0.6, so 0.9. 0.9 plus 0.6, 1.5. 1.5 plus 0.6, 2.1. 2.1 plus 0.6, 2.7. Or you can take the two values, add them, and divide by 2. So this would give you 5.4, and 5.4 divided by 2 is going to be 2.7. Okay, so now that we have our midpoints, what we're going to do now is look at this going, this is 1. So I need to be way over here at 3, which is going to give us a very minute value. But now keep in mind my interval, though, is 1 to 6. So here's 0.6, here's 3, and that's going to be my rectangle I'm going to draw. And this is 0.6. This is 1.2 over here. Halfway point is 0.9. This is the guy that goes up to the thing. And then I can finish off my rectangle. And this is when you start seeing that you're grabbing inside and outside. And you're grabbing values that are inside and outside. And so down here, there's a little bit of a 1. Okay, 1.2 to 1.8. So 1.5 would be around, right about here. And if I take this guy up, then my rectangle will extend that way, and then it will extend out this way. And again, some of the inside and outside. 2.1 is my next midpoint. That's going to go out to 2.4. So we come up, and we expand our rectangle. I know my rectangles are really, really bad, but you do need to know how to do this. And then the very last one comes here. Okay, you do have to know how to draw your rectangles. They will ask you to do this. Okay, now that I have my rectangles, and I obviously know that I'm going to have more of an accurate answer compared to the others, because while I'm grabbing this bit, I'm not grabbing this bit. While I'm grabbing this bit, I'm not grabbing this itty bitty amount here. Same over here. I'm not grabbing this bit, but I'm grabbing this little bit out here. So they kind of counteract each other. So these values, this is going to give me 0.026568, 0.634494. And I would really like you guys trying to put this in the calculator yourself to get the answers, making sure you get the same ones. 2.24436. 3.80675, and 3.1155. Multiply all of these values by 0.6, and you get 0.01595. At 0.9, we're going to get 0.380696. At 1.5, we're going to get 1.346618. At 2.1, we're going to get 2.28405. And the last one's going to give me 1.86935. And then if I added all of those values together, we're going to get a 5.8966. And you're going to find that this is actually quite close to accurate to the actual answer. I am going to throw this into the calculator to see what we get. See, this is going 0 to 3. All of that mess, x. And the more accurate answer is 5.77. So even 5.777, if I round it to 3 decimal places, 5.777. We definitely see that the midpoint is still giving us an overestimation, but it's much closer to the accurate answer than the other two are, even though the left or the right gave us a fairly close approximation as well. Okay, I do realize this already is at 15 minutes, but I want to get us going on the next one here because we're doing the same problem, But this time we're going to use n equaling 10, just so that we can compare the answer between 5 intervals and 10 intervals. And so everything's going to be done. This one here, we will talk a lot more about it in class, because I just realized I don't have it set up on my computer here to do this one with you. But this is more to get the approximations going in there and seeing and comparing them. So when I did 5 on this, my left I got 5.155. On the midpoint, I got 5.8, actually, because I didn't round it earlier and I'm trying to round it down to 3 decimal places now. 5.896, that 6 is, the 6 is going, okay, no, I had it. 5.897, and then the right is going to round to 5.917. Now keep in mind, I threw this in the calculator and we got a more accurate answer of 5.777. Now we're not going to do this one at 25 at all. And I was looking to see on my notes if I had it written down at one point. But when I do 10 of these, the left one is going to give me 5.526. The midpoint is going to give me 5.807. And then the right is going to give me 5.907. Okay, I mean, we got a lot closer even on the left, and even this one's closer, and we know that the actual answer is 5.777. Okay, I'm looking here to see if I have it on my notes somewhere where I had 25. I'm looking, and I don't know that I don't have them written out. I don't have the answers written out. So I don't have the ones for 25, unfortunately. So so I can't give those to you. But we will talk about this with regards to in class, and we'll go more into detail on this one here, doing the 10. And that's going to be just for practice. We're going to do that more so in class for the practice. So we'll do the 5s together in class, and then again, the 10 we'll do as just a practice run for everyone. All right, so you're good to go to get started on the notes. We are going to go skip all the way to section 5.5. And in 5.5, we're going to identify the, I'll show you how to go into the calculator and get those actual answers. It's actually in 5.4, but because we're going to jump to 5.5 because it's just another one of these. And it's just a different way, and it's actually more accurate than even these are. Okay, so good luck on this. Go ahead and get started on the homework, and then we'll get going tomorrow on 5.5.